So there's some things that will still be figured out coming into next year. Let me get this back up. Well, we're going to finish up the review sheet today, and then your test will be tomorrow.
Oh, dang.
Yep.
I guess she didn't send in
You're good.
the transcript or things to you. She said she did.
Y'all know the difference between an official transcript and a unofficial transcript? The high school has a seal on it on the outside, or essentially the high school, Miss Blossom put it in an envelope and sealed it. That's the only difference. It's the same piece of paper. It's just the high school officially sealed it so you didn't touch it or change anything. Same piece of paper, except the official one costs you money at the college level. We'll look at 41 first, and then look at some of the others, the inequalities, bless you, where they're not the same base. Now, one of the main giveaways for most of these problems here that we'll be doing a one-to-one or getting the bases to be the same is if there's variables in both exponents. So we look at 41, because we looked at 40 on Friday. 41, on the left-hand side, we have this 512 to the 5x minus 1. On the left side, we have 1/8 to the negative 4 minus x. There's variables on both sides of the exponent, so we're going to want to get the bases to be the same. Now, there's two different numbers we can make 512 and 1/8 be the same as. But it would be nice if I can make both of them into a base of 8. Can we multiply 8 by itself a number of times to get 512? So 8 times 8 is 64. Times 8 is 512. So what I can say is that the left-hand side is 8 to the third to the 5x minus 1. On the right-hand side, we can move the 8 to the numerator, but anytime we do that, we have to make the exponent negative. We change the sign from positive to negative or negative to positive. Since it was just 8 to the first, we move it up, it's 8 to the negative 1. Now we can distribute our exponents. 3 times 5x is 15x. Minus negative 1 times 3 would give us negative 3. On the other side, we're going to multiply both the negative 4 and negative x by negative 1, which will just give us x plus 4. Now, since the bases are the same, the exponents have to be the same as well. So 15x minus 3 has to equal x plus 4. What can we do next? Yes, we can minus x from both sides, telling us that 14x minus 3 is equal to 4. And then we could add 3 to both sides, telling us 14x is equal to 7. Exactly, divide both sides by 14, telling us x is equal to 1/2. And that's it. Now, since we're talking about exponents, numbers in the exponent, our variable's value could be positive, negative. What's in the exponent's value sign does not matter. Because after we plug x back in, what these turn into could be positive, they could be negative, or they could be 0. Any of those work fine. Any questions on this here? We did 42 in class on Friday, so we can go on and look at 43 next. 2e to the x minus 7 equals 5. Now with this one here, the first thing we really want to do is to get e by itself. So we could add 7 to both sides, which will tell us that 2e to the x is equal to 12. And then we would divide both sides by 2, telling us that e to the x is equal to 6. And last but not least, we need to ln. Yes. Yep. Thinking of the roots chapter. Because ln of e is 1, and because of our properties of exponents, we can move the x to the front, giving us just x. On the other side, we have ln of 6, and ln of 6 we can calculate in the calculator. 9, and we get 1.792. Go to 3 decimal places, or if you don't feel comfortable with 3 places, go 4 or 5. That's fine. Either way works just fine. And when I say that, because sometimes we get those decimal that's 0.9995, and you're not sure, do I need to round it all the way up to the next whole number, or do I need to leave it here? In those, if you want to go 4 or 5 places out instead of 3, I'll take that. Or if you wanted to leave it as 0.995, I would take that too. Yep. So just leave it as the way that you feel comfortable. As long as it's the correct answer, I'm going to take it. And sometimes if the decimal looks really weird, I'll look back at what you have before it. So x equals ln of 9, or ln of 6. If you got that right, but for some reason the next step, this was way off, I'll go on and take it as long as that's right. If you'd have put x equals ln of 9 and then got it, then I'll start marking. You're welcome. So, do we need to look at 44? Because 44 is the exact same thing we did. On the last one, here we would minus 9, divide by 6, and solve from there. We can go on and look at it if you all want. So, as we just said, the first thing we can do is subtract 9, which will tell us that 6 times e to the 2x plus 1 is equal to 6. Then we divide both sides by 6, which tells us e to the 2x plus 1 is equal to 1. Yes. Any questions on how we got e by itself? Now that we have e by itself, we're going to apply the natural log to both sides. Because ln of e simplifies to 1, leaving us with 2x plus 1 is equal to the natural log of 1. Now we just need to solve for x. So the first thing we can do is subtract 1 from both sides, telling us 2x is equal to the natural log of 1 minus 1. And last but not least, we would divide by 2, telling us x is equal to the natural log of 1 minus 1 over 2. Actually, if we plug that into the calculator, we get negative 1/2. And the reason that this works out the way that it does is based off the natural log of 1 is 0. Natural log of 1 is 0. So 0 minus 1 over 2 is negative 1 over 2, or negative 1/2. And we could have typed this into the calculator. Enter ln of 1, close parentheses, minus 1 over 2 gives us negative 1/2. Any other questions on this here? Now, when you type that into the calculator, do make sure to close the parentheses after the ln. Because if you leave that parenthesis open, it will actually give you an error that it does not work. Enter. If I say delete, enter, error, domain, doesn't work. Because it's going to put those, anything after that, into the parentheses. Because negative, or 1 minus 1 is 0. We can't take the natural log of 0, so it doesn't work. But here the answer is negative 1/2. Any other questions on this one here? Let's go on and look at 45. 7 to the x equals 3. So we do have one term on either side. There's no way we can write 7 as 3 or 3 as 7. So what can we do to both sides? What can we apply to both sides? Log what? Log base 7. And we do this to really simplify the left-hand side, the side where the variable is, because we can move the x out front. X equals, because log base 7 of 7 is 1. 1 times x is just x. On the left right-hand side, we have log base 7 of 3. And at this point here, we could type this into the calculator. So we can go math, log base 7 of 3, and hit enter, and we get 0.56547. So we can say 0.565, 0.56547, 0.5655. Any of these work. As long as you're not farther away from this than 0.001 or 0.002, or within a few thousandths, 1 or 2 thousandths of the answer, I'm fine with that. We get farther away than that, then I'm going to have to start counting off. But again, before I start marking off, I will double check and see what you had before you approximated the answer. Any other questions on these here? Any questions on everything we've done so far? Questions on 46 or 47? Either one of those that y'all want to see worked. 47. Since the logs are the same, what's inside has to be the same as well. So we're saying that 3x plus 2 has to equal 4x minus 5. Because what we're essentially saying is that I could put both sides to the base at e. E simplifies with ln, e simplifies with ln. So what's inside is equal. Now we just need to solve for the value of x. So the first thing we could do is, well, I'm going to subtract 3x. Because 3x minus 3x is 0, leaving us with 2. 4x minus 3x is x minus 5. Yes, because we can add 5 to both sides, telling us x is equal to 7. And we could check this here and see that we do get a positive number if we plug 7 into both 3x plus 2 and 4x minus 5. More specifically, it would give us this exact same thing. Any other questions on this here? Are you ready for the next one? questions on 48 or 49? Well, they are the exact same thing we just did, because we set what's inside the parentheses equal, since the logs are the same for both. Solve for the value of x. So, yeah, we would just consider the 38 to be in parentheses. Most common notation is if it's only a single term, we don't have to put the parentheses. I think it's better to put them, especially on the off chance we do have something after it.
Can we go back and do 46?
Mm-hmm. Yeah, so the first thing I would want to do is set both sides to log base 11 of our 11 to the 6x plus 2 equals log base 11 of 38. And the reason we do this is because, one, properties of exponents, the 6x plus 2 would move to the front. And log base 11 of 11, what's left over is 1. And at this point here, we just need to solve for the value of x. We need to get x by itself. So we could subtract 2 from both sides. These cancel, telling us 6x is equal to log base 11 of 38 minus 2. And last but not least, we would divide both sides by 6, telling us x is equal to log base 11 of 38 minus 2 divided by 6, which is approximately we get this here. Yep. Any other questions on these here, on 46 or 47? Let's look at 50. Let's look at 50, because I know 50 has a little bit of a hitch, something I've talked about and hinted on, but it would be good to see. Now, the logs are the same on both sides. So if the logs are the same, it means what's inside has to be the same as well. So we're saying x squared minus x minus 6 is equal to negative x. And really what we're doing to get here is applying both sides to the base of 2, because 2 to the log base 2 cancels, 2 to the log base 2 cancels. Now that's not really important, because again, we have that property of if the logs are the same, what's inside is equal. This is why. Now we just need to solve for the value of x. Well, since we have a higher degree polynomial function, we need this thing equal to. So the first thing I can do is add x to both sides. And just like we hoped, negative x plus x is 0. On the other side, we have x squared. Well, negative x plus x is 0. X squared minus 6 equals 0. Can we factor this? No. Because what we're looking for is two factors of 6 that will either add together or subtract from each other to give me 0. That just doesn't work. But do we have a middle term? Because middle term would be term with just x to the first power. Do we just have a term with x? No. So what we can use is the square root method, which says I can add 6, telling me x squared is equal to 6. At which point we can square root both sides, saying x is equal to plus or minus the square root of 6. So normally, which one would we not want out of the plus or minus 6? The minus square root of 6, yes? That's Gmail notifying me that I got a message. Now, if I plug negative square root of 6 in, so we have negative square root of 6 squared minus negative square root of 6 minus 6 on the left-hand side. Yes. Now, for this here, negative square root of 6 squared is actually 6. And I'll plug that in. So if we said parentheses, negative second square root 6, close parentheses squared, we actually get 6. We could have actually typed the whole thing in. Not the log itself, but I would just say what's inside minus parentheses. 1 second. Negative second square root 6 minus 6. So we had 2.44989743. But the big thing is that is an irrational number, but it's what? It is positive, yes? Because if we approximated this, we would actually approximate it to the square root of 6. Because negative square root of 6 squared is 6. Here the negative and negative gives us plus square root of 6 minus 6. Well, 6 minus 6 is 0, leaving us with just the square root of 6. Now on the other side, log base 2 of negative square root of 6. Well, negative and negative make a positive, so we have the square root of 6. So for here, when x is the negative square root of 6, we plug it into both sides. What's inside here is positive, and so the negative square root of 6 works. So that is a correct answer. Now, instead of erasing all that, I could have just erased the negatives, but oh well. Because what we can also check is the positive square root of 6. Well, we could stop at this point here. I don't have to touch anything on the left-hand side. Because if we look at the right-hand side, we have log base 2 of negative square root of 6. Is that as simplified as we can get it? I mean, there's no other negatives we can do. There's nothing we can do to it. So is there any way I can have log base 2 of negative square root of 6? No. And even if we simplify the other side, it tells us that we have log base 2 of negative square root of 6 is equal to log base 2 of negative square root of 6. Both sides are the exact same, yes? Well, yeah, they both have log base 2 of negative square root of 6. But because I can't have log base 2 of negative square root of 6, it doesn't work. Even though both sides are the exact same, it just doesn't exist. So the correct answer for this here is not the positive case. This one here is actually the negative square root of 6 is the correct answer for this one here.
Will we have one left for
Don't think so,
Okay.
but most of it, to figure out which one it is, you're just plugging it back in. We don't have to do the log base 2, but all I'm doing is plugging the values of x back in all the original spots and seeing, do any of these turn out to be a negative? Because if any of those spots turn out to be negative, that solution doesn't work, and we'll go with the other one. Does that make sense? So especially on these here, we could have just typed in parentheses negative square root of 6 squared minus square root of 6, or just type the variables in, hit enter, and see, are they both positive? Is all of them positive, or one of them or all of them negative? If it's negative inside the log after we plug it in, it doesn't work. If it's all positive, we're good. Any other questions? Solve each logarithm to 3 places. So this one here, we're going the other way around. Which one do we want to look at first? 51. To simplify this log, we need to do what? Put both sides to the base of 7. Log base 7 of 7 will simplify out, telling me that I have 4x plus 9 is equal to 49. On these here, well, as you just saw, we did simplify it, yes? On all the previous ones where we had logs, well, we've come to realize most logarithms don't work out to be as nice as 7 squared. Because if it works out to be a nice number, we can go on and plug it in and simplify. If not, might as well leave it as the natural log or whatever it is until we get to the end. Now we just need to solve for x. So the first thing we can do is and that's it. Any questions on this here? Questions on 52? We can go on and look at 52. What do we need to do first to 52? Yes. Because we want to apply the base that's going to simplify out the log. So here we're going to apply e. And the terminology for doing this is just funky. Because we're putting both sides to the base of e, which is not something you normally will use in a sentence, or after this, you're not going to ever say it again. Yes. So to be, I think, 100% specific, it is the inverse. It's the opposite operation. Not so much an operation, it's the opposite function. It's the inverse function. Now, here, e to the 7 is not a nice number. So we'll leave it. We will type it all into the calculator at the end, because the more we approximate a decimal as we work through this, the farther away from the actual answer we're going to get. So the first thing we can do is add 2 to both sides, telling us 6x is equal to e to the 7th plus 2. And last but not least, we'll divide both sides by 6, telling us x is equal to e to the 7th plus 2 divided by 6. So 183.1055, I believe the answer key says 0.106. Either works fine. Any other questions on this one here? Any questions on 53 or 54? .54, since the ln is not by itself, the first thing we'll do is add 4 to both sides, telling us the natural log of 6x is equal to 19. Now that the natural log is by itself, we would add e to both sides. This e and ln will cancel, telling us that 6x is equal to e to the 19. And last but not least, we would divide by 6, telling us x is equal to e to the 19th divided by 6, which is still going to be a massive number. So we'll leave it as this here, because it doesn't give us 3 decimal places, so I will take this here. Because we could probably get to the 6th decimal place or 3rd decimal place. We just have to subtract. Yeah, on the graphing calculator it doesn't. 297475050. It's 042 is after it. Because what we could do is subtract the our whole numbers from it, which the calculator will move the decimal over. Direxia. Any other questions on these here? Question on anything we've done so far? So, wrong way. So we can look at 55, and then we'll look at 1 or 2 of the inequalities. So 55, whenever we have 2 or more logs added together, we can rewrite it as a single logarithm with what's inside being multiplied together. So whenever we have 2 or more logs being added, we rewrite them as a single log with what's inside being multiplied. We won't have any with a subtraction dealing with the division. If they show up like this here, they will mainly be rewriting it as multiplication. Our next step is to put both sides to the base of 5, because 5 to the log base 5 simplifies out, leaving us with x plus 4 times x plus 1 equals 25, because 5 squared does simplify to a nice number. Now on the left-hand side, we will need to distribute, so x times x would give us x squared. X times 1 is x. 4 times x is 4x, and 4 times 1 gives us 4. And we can combine like terms. X and 4x give us 5x plus 4 equals 25. And whenever we have a quadratic or a polynomial with a degree greater than 1, we want to get everything on the same side. So if we do that, we get x squared plus 5x minus 21 is equal to 0. Now at this point here, we can graph it, or we can factor it, or use the quadratic formula. If we factor it, since the 21 is negative, our signs are opposite. Factors of x squared are x and x. And the factors of 21 are 1 and 21, 3 and 7. So the one that we want is 3 and 7. Nope, doesn't look like this is factorable. I could try that again. No. So that means we have to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4 ac all over 2a. Now, if you notice, I didn't plug a in either spot, because what is the value of a? 1, and anything times 1 is just whatever we started with. So I could put in 1 and 1 here, but it's not going to make that big a difference. Questions on any of this here? Now, at this point, we can go on and type this into the calculator. Alpha y equals enter. So we have negative 5 plus second square root 5 squared minus 4 times 1 times negative 21 all over 2 times 1. So one of our answers is 2.72015 going on. Now the other one, so we can go up here and I'm going to select it again. I change it from plus to minus, and we get negative 0.72015. Are our two answers. But we know the negative one is not going to work. Because if we look back at the original problem, the two spots that x shows up is here and here. Is there anything in those two spots that's going to turn the negative positive? No, because our x is negative 7.72. Well, negative 7 plus 1 is negative 6. Negative 7 plus 4 is still, well, negative 3. They're both negatives, so the negative doesn't work. But the negative, or the positive 2.72, in both of those places will still work. It'll still be positive, so this is the correct answer. Questions on any of these here? So we'll go on and finish up with an inequality. Either one of these that we want to look at. So we'll look at 58. And when we look at 58, the first thing we need to do is apply base 7 to both sides, because log base 7 of 7 will cancel out, leaving us with x plus 2 is less than 7 to the 4th. Now we could have plugged 7 to the 4th into the calculator and got a decent answer, because it'd be the same as 49 squared. Now what do we need to do to get x by itself? So x is less than 2,399. Now this one here is inside the log, yes? So what's inside the log cannot be 0. So we're saying that x plus 2 has to be greater than 0. Minus 2, so x has to be greater than. Here, if it had said greater than, x is greater than 2,399, then we don't have to worry about it. This only takes place with logs, if we start out with a log. If we start out with an exponential or an exponent, then we wouldn't have to worry about it. If you do have any other questions, please let me know. Your test over this is 2 multiply. If you still